Hello, this is a video lesson for Unit 1, Lesson 2, which is writing expressions with variables. Our learning target today is that we can use variables to write expressions. Now, vocabulary is going to be really important in this lesson because what we're doing is we're going from words to mathematical expressions. So we're going to have like a sentence or specific word instructions, and we're going to have to either perform or write out operations in an expression given that word. So the first word we're going to deal with here is sum, and we're just going to write right next to it that this is addition. Put an addition sign. Difference is another word for subtraction. These aren't all the words that we're going to need to know, but they are some really important ones. Okay, product is another word for multiplication. And quotient is another word for division. To square something, and don't get this confused with square rooting, because in this unit we really don't do square rooting. Squaring is the same thing as raising something to the second power or multiplying something by itself. That'll show up in some of our assessments, so make sure you're aware of that one. Okay? So now we're going to slide into this table activity. This is really the biggest focus of day one. You'll see the day one homework involves a lot with this table, and this is something that shows up on the quiz and the test. What we're using this table for is just an organized way to perform some different operations. At the beginning, we're going to do it for a number. So the first focus we're going to have is this column. We're going to work downward through this column, starting with the number 8, and then we are going to perform whatever operations the directions tell us to. So the directions start off by telling us to write down the number. So the number's there, 8. Then they tell us to find the product of your number and 2. Well, product means multiplication. Okay, so they're saying multiply your number by 2. Well, if I take 8 times 2, I am going to get 16. Next, it says increase your result by 5. Increase, while that wasn't one of the words up here, we have to think about what operation that would be. And increasing something means you're going up by whatever that number is, or you're adding that number. So in this case, we're adding 5 to whatever number. The result from the previous operation was 16, so we're going to add 5 to 16 to get 21. Now they tell us to multiply. Well, that's easy. We know what multiplication is. Tell us to multiply that by 3. At this point, if you need to use a calculator, you may. We're going to multiply 21 by 3 to get 63. And finally, decrease is another word that is not on our list up here, but decreasing means going down or subtracting by 5. So be careful here. Don't do 5 minus 63. We're taking the 63 and we're decreasing it or subtracting it by 5 to get an answer of 58. And we've filled out that first column of the table. We're going to do the same thing again, but this time we're going to do it in the second column with the number -3. So we're going to do exactly the same thing. We're going to start by multiplying by 2. Well, -3, the first number, times 2 is -6. Then we're going to increase by 5, which means adding 5. -6 plus 5 is -1. Then we're going to multiply that 1 by 3 to get -3. And then we're going to decrease that result by 5, meaning subtract 5 to get -8. And now we're done with the second column. Now we get to the third and final column. And in this last column, what we are going to try to do is we're going to try to do the same process, but instead of doing it with a number where we can use a calculator, we are going to use a variable where we're just going to modify the variable as we go. Okay, so we're going to start off by looking at multiplying this n. Our first number in this case is n. We're going to multiply that n by 2. Well, an easy way to write that in math is just 2n. That represents 2 times n. We're going to increase that result by 5. Well, we need the 2n. We still need to show that the 2 is next to the n, meaning multiply by 2. But then we need to add 5. So we're going to do that right next to it. 2n, and n still getting multiplied by 2. And now we're adding 5 to it. 2n plus 5. Next, we want to multiply this whole result by 3. So you want to be careful with that. We're going to multiply the whole result by 3. So the 2n needs to get multiplied by 3, making a 6n. And the 5 needs to get multiplied by 3, making a 15. Finally, we want to decrease the result by 5. Well, we can take 5 away from the 15, but we're not going to take 5 away from everything. Well, 6n plus 15 is everything. So it's 6n's and 15 1's. When we take away 5, we're just taking away 5 of the 1's. We're not taking away any of the n's. So we're still going to have 6n's, but we're going to have 5 fewer 1's. So we're going to have 10. 15 minus 5 is 10. And now we have an expression that represents all of those operations that we did on the left. What I would encourage you to do right now is to pause the video and try this table on your own. Then, after you're done, you can come back and watch the video or even fast forward in this video to see the table filled out to see if you did it correctly. If not, if it's not correct, you can go back and watch what I did and catch where your mistake happened. So pause right now and practice this problem. All right, so I'm assuming you're back and we're going to walk through this problem. Write down a number. Okay, they tell us here to start with the number n. So I'm going to start with the number n. The product means multiplication. The product of my number n and 2 is 2n. Now they ask me to increase my result by 5. Increasing is adding 5. Okay? It's really similar to that last problem. We're going to increase our result by 5. Well, I can't add 5 to the 2n. I just put them next to each other. 2n plus 5. Now, I'm going to multiply by 5. That means I've got to multiply everything by 5. 2n times 5 is 10n. 5 times 5 is 25. Finally, I'm going to subtract 25. Just like the last example, subtracting 25 is just going to get rid of that many 1's. We have 25 1's. Well, 25 of them are gone, so we're down to 10n by itself because plus 25 minus 25 becomes 0, and that 0 disappears. So we just have 10n when we take away 25. Remember, subtraction. We're doing subtraction there. And finally, we're going to divide the whole thing by 10. Well, this is easy. There's only a 10n. So divide that by 10, and you get n. So this is a weird one where we actually ended up with the same number that we started with. So it's kind of fun. If you want to try it, you could. Take any number, plug it into these directions, and you're going to get back that same number at the end. For example, if I take 5, multiply it by 2, I get 10. Increase it by 5, I get 15. Multiply that by 5, I get 75. Subtract 25 from it, I get 50. And divide it by 10, I'm back to 5. So no matter what you plug in, you're always going to get the same number at the end for this particular example. But that's just kind of fun math to think about. Really, what I need to see is that this table is done correctly. Again, I'm going to encourage you to practice these two problems without watching the video, and then come back and use the video to see if you got it right. All right, let's try this one. Starting with the number 11, we're going to decrease that by 4. Decrease means subtraction, so we're going to subtract 4 to get 7. And we're going to triple the result. Tripling means we're going to multiply it by 3. So 7 times 3 is 21. Write an expression for any number n. So we're going to do this one with n. Decrease n by 4, and you're going to get n minus 4. Triple your result, that means multiply everything by 3. N by 3 makes 3n, 4 by 3 makes 12. Now, we're going to do one more example that we want to do, any number that we want to do. So I'm going to do the number 2. It's nice and small. I'm going to decrease it by 4 to get negative 2, and I'm going to triple it to get negative 6. This column here will look different if you practice this problem on your own, because you picked whatever number you wanted. So you didn't have to pick 2. That was just the number I chose. Okay? Now, we slide down to the second problem down here. And I want you to see that it matters. This problem's really, really similar. We're still decreasing by 4, and we're still tripling. Still decreasing by 4, still tripling. But I want you to see how order of operations matter. To triple before you decrease is actually going to give you a different result. So let's watch that and see if that's true. So we're going to triple our number. 11 times 3 is 33. And then we're going to decrease that by 4 to get 29. See how we're getting a different result here than we did last time? Now we're going to do this for n. We're going to have n, we're going to triple it to make it 3n, and then we're going to subtract 4 to get 3n minus 4. And you see that it's a little bit different than it was before. And again, we could pick whatever number we want, plug it in, and do a third column example here. So we're going to plug in 2 again. I'm just picking 2 for fun. Tripling it to get 6, subtracting 4 to get back to 2. All right, so we've got a few more examples here to do. We're just going to do, it's kind of the same thing, but we're just doing it straight from a sentence and not filling out this whole table. So write an expression to show the sum of W and 8. Well, sum means addition, so I'm going to add W and 8. W plus 8. Write an expression to show 5 less than x. If you're feeling confident at this point, you can at any point pause the video, try the rest of these problems on your own, and go back and check the answers using the video. So this one's a tricky wording problem. 5 less than x, it means subtraction, but you have to be careful with the order here. If you're going 5 less than x, you're actually taking x and decreasing it by 5. So it's x minus 5. Writing 5 minus x would actually be wrong, so please be careful. Next one says write an expression to show the product of p and negative 3. When we write product, it's multiplication. When we write multiplication of a number and a variable, we always put the number first. It's not wrong to write p times negative 3, but the best way to write this would be negative 3p. The next one says write an expression to show 2 less than the sum of c and 5. Okay? We have to be careful here. When you see something like the sum of, they mean we need to do this first because this is like a parenthesis that c and 5 are kind of getting connected. And remember, we have to talk about parentheses first if we're following PEMA or PEMDAS. Okay? So I'm going to take the sum of c and 5, c plus 5. And I'm going to do 2 less than that. But I need that c and 5 to be together. So I'm going to do 2 less than that. If you left this here, that would be totally fine. But I would go a step further and say, well, with addition inside the parentheses, I can't really do anything with that. So I'm going to move forward and eliminate the parentheses and get to c plus 5 minus 2. And that can really turn into c plus 3. So c plus 3 is the best answer, but I would take c plus 5 minus 2. Either answer would get accepted. Lastly, write an expression to show 2 decreased by the sum of c and 5. So this one's a little bit different. Okay? We are going to write 2 decreased by the sum of c and 5. So again, sum of c of 5. That's addition. C and 5 are linked together kind of within parentheses. And we're going to have 2 decreased by that. So 2 minus c plus 5. This is kind of a tricky problem because it's going to require the distributive property, which we haven't learned yet. So I'm actually just going to leave this here. We're going to stop at this point. And like I said, on that previous one, if you wanted to stop here, that would be totally okay as well. Finally, a few last real-world examples. Michelle purchases C Cokes, so C is a number, D diets, D is also a number. Write an expression for the number of drinks purchased. Okay? Well, if she's purchasing that many Cokes and that many diets, altogether, she's purchasing C plus D drinks. Think of it this way. If she purchases 5 Cokes, so if we were just put in the number 5 for some reason here, and 4 diets, then 5 plus 4, 9 would be how many total drinks she drank or she purchased. The area of a triangle is equal to half the base B times the height. So half the base, that means multiply by 1/2. B is some length we don't know. Times means multiplication. And the height, h, is some number we don't know. So we're going to multiply B by 1/2, so 1/2 B. And we're going to multiply that by the height. So we don't really need to draw the dot. It's okay to draw it. But really the answer here is just going to be 1/2 B times h. Final question of this lesson. A new TV costs $20 more at Best Buy than at Walmart. Is the cost if the cost at Walmart is $W, write an expression for the cost at Best Buy. Okay? So we are going to just be writing how much it costs for Best Buy. So a new TV costs $20 more at Best Buy than at Walmart. So if you take the Walmart cost, to get to the Best Buy cost, you'd have to add $20 to it because the Best Buy costs $20 more than the Walmart TV. So we would take the W, the price at Walmart, and add 20 to it to get the Best Buy cost. And that's the end of this lesson.